Imagine a world where houses are no longer built with the sound of hammers, stacks of bricks, and construction workers laboring under the scorching sun for months. Imagine if a house could be printed, not built slowly, not assembled piece by piece, but literally printed, just like a regular printer prints on paper, only on a much larger scale. Wall by wall forming automatically, structures emerging layer by layer, and within days or even hours, an entire building could stand complete. This is no longer a far future concept. It is already happening today. This technology is called 3D construction printing, or more simply, 3D printed houses. And today, we are going to explore how this technology works, why it could transform the construction industry forever, and whether one day humans will no longer need traditional builders as we know them. To understand this, we must start with the basics: how houses are normally built. For thousands of years, construction has not changed much. We gather materials,
Bricks, cement, steel, wood. And then humans manually assemble them piece by piece based on architectural plans. This process requires a huge amount of labor, a long time, and significant cost. Even a simple house can take weeks or months to complete. And if a small mistake happens, the entire process can be delayed. Now imagine if all of this could be automated. Not humans placing bricks one by one, but machines doing it with perfect precision. This is the core idea behind 3D printed houses. At its foundation, the technology uses a giant printer. Not a paper printer, but a machine large enough to resemble construction equipment. This printer moves according to a digital blueprint. And instead of ink, it uses special materials like concrete mixtures, fast-drying cement, or composite construction materials. The machine then prints the house layer by layer, like drawing lines in the air that solidify into real walls. Each layer hardens quickly, and slowly, the shape of a house begins to appear. From the outside, it may look almost impossible, but technically, the process is very logical. It all starts with a digital design. Architects no longer rely only on paper drawings. They create detailed 3D models on computers. Every corner, every wall, every room, everything is calculated digitally with precision. This model is then sent to the 3D printing machine, and the machine begins working. There are no workers laying bricks one by one, no repeated manual measurements. Everything is controlled by a computer system. But what makes this technology truly revolutionary is not just speed, it is efficiency. In traditional construction, a lot of materials are wasted. Measurement errors, cutting mistakes, or last-minute design changes. All of this leads to inefficiency. But in 3D printing construction, material is used with extreme precision. Only what is needed is printed. Nothing more, nothing less. And as a result, costs can be significantly reduced. But the question is, how can a machine build something as strong as a traditional concrete house? The answer lies in materials science. The concrete used in 3D printing is not the same as regular concrete. It is specially engineered to harden quickly, but still remain strong once set. It must be fluid enough to be printed, yet stable enough to support the next layer. This is a delicate chemical balance. Even a small mistake in the mixture can cause structural failure. And this is where material engineering plays a crucial role. But this technology is not just about machines and materials. There is also a highly advanced control system behind it. Sensors, simulation software, and algorithms that guide every movement of the printer. The machine must ensure every layer is placed perfectly. Otherwise, the structure could become unstable. Some systems can even adjust in real time based on environmental conditions, such as humidity, temperature, or material pressure. Now, let's imagine the process in real time. An empty plot of land. No construction workers carrying bricks. No trucks delivering materials every hour. Only a large machine, often shaped like a robotic arm or portal structure. The machine begins to move. The first layer of the house starts forming on the ground. Lines of liquid concrete appear like paste being precisely extruded. Within hours, the foundation is visible. Within a day, walls begin to rise. Within a few days, the main structure is complete. Compare this to traditional construction, which can take months. The difference is massive. However, of course, this technology is not perfect. There are still many challenges. One of them is scale. Not all types of buildings can be easily 3D printed. Simple houses are more suitable than complex skyscrapers. Another challenge is regulation. Building codes in many countries are still based on traditional construction methods. Safety standards, certifications, and approvals are not yet fully adapted to 3D printed structures. There is also the challenge of perception. Many people still believe that a printed house may not be as strong as a traditionally built one. Even though technically, many 3D printed structures have already proven to be durable and safe. But changing human perception takes time. Still, the potential of this technology is enormous. One of the biggest impacts could be on the global housing crisis. In many countries, housing prices continue to rise. Construction costs keep increasing, and many people struggle to afford a proper home. With 3D printing, construction costs could be significantly reduced. Building time could be shortened, and housing could be delivered faster to areas in need. In fact, some experiments are already using this technology to build emergency housing in disaster zones, where speed is critical. In situations like earthquakes or floods, houses could be printed directly on site in a very short time. However, this also raises important questions. If houses can be printed by machines, what happens to traditional construction jobs? Will millions of workers be replaced? Or will they adapt into new roles, such as machine operators, robotics technicians, or digital construction designers? Like every major technological revolution in history, this is not just about machines. It is about people, about how society adapts to new ways of building the world. And even more interestingly, this technology is still evolving. Some companies are experimenting with multi-story 3D printed buildings. Others are developing eco-friendly materials. There are even concepts of printing houses on the moon or Mars. Imagine that. Humans do not transport buildings from Earth. Instead, they print them directly on another planet using local materials. An idea that once sounded like pure science fiction is now being seriously explored. But amid all this progress, one question remains. Will 3D printed houses completely replace traditional construction? Or will they become part of a hybrid future in architecture? We may not know the answer yet, but one thing is certain. We are witnessing the beginning of a major transformation in how humans build shelter, from bricks to digital data. From manual labor to machine precision. From traditional construction to automated printing. And perhaps in the future, when someone stands in front of their home, they will no longer say, "This house was built," but instead, "This house was printed." And that is when we realize the future of architecture has already begun.